Hello, my geometry students. We are up to day 9, so it's another day of proofs with quadrilaterals. This time, we are talking about what do we need to show to be able to conclude that ABCD is a parallelogram. So that's different than yesterday. Yesterday, we were given parallelogram and then concluding stuff. This time, it's saying, what's like the minimum amount of work I have to show to be able to say this thing is a parallelogram? So there's a bunch of different ways that we can do it. The first one is by using, what's inherently obvious about a parallelogram, and that's the fact that if I have two pairs of opposite sides parallel, then that's enough to prove that it would be a parallelogram. All right, so we're going to use all the properties to work our way there. The next one, if I have two pairs of opposite sides congruent, I'm going to abbreviate a little bit here. That would be enough to make it a parallelogram. The third way to do it is if you have two pairs of opposite angles congruent. And then there's one more before we get down to the diagonal one. And this one is one that might not be obvious. If you can prove that you have one pair of opposite sides that are parallel and congruent, that would be enough to prove it's a parallelogram. So like you'd have to show like the top and bottom, let's say, are parallel and congruent. That's how you could say that, all right, this thing has to be a parallelogram, which is kind of cool. If you have the diagonals, there is one more way. So if you think about a property of parallelograms is that the diagonals bisect each other. So if you can prove that the diagonals bisect each other, you can prove it's a parallelogram. So we're going to say that the diagonals bisect each other. Now, of course, this is shorthand. Every single one of these should be a quadrilateral whose diagonals bisect each other, and a quadrilateral with one pair of opposite sides parallel and congruent. Hopefully that's obvious. All right, down at the bottom, some helpful steps that we're going to see in the proofs that follow in these notes here would be the idea. How do we prove lines parallel? Well, if we can show congruent alternate interior angles, that's enough to prove that the lines are parallel. That'll be super helpful. If we can prove congruent triangles, then we can use CPCTC. So corresponding parts of congruent triangles are congruent. That will be helpful. So if we can show this, we get all sorts of stuff from there. Other things that we can say to prove bisectors, that's a good one to talk about. If we have two congruent segments, write it out, segments, that would imply that we have a segment bisector. We did that back in our triangle proofs. Stuff that's always good to use, vertical angles. Implies that we would have congruent angles, and feel free to use that angle abbreviation anywhere you like. And then reflexive property, that will still be super useful here. So those are just some of the ones that will be helpful to recognize and to look for within the proofs themselves. Right? So let's flip it over. These first few, short and sweet, which is kind of nice. So on to page 35 in your note packets, it says complete the following proof. So you were given a pair of congruent triangles. That is not typically something that we are used to being given. But remember, if we have congruent triangles, what are the parts that we can steal from them? All right. So there's a lot of ways to do this. But start with the given. That's how we always start our proofs. So triangle ABD is congruent to triangle CDB because it's given. And then you're trying to prove that this whole thing's a parallelogram. So parts that could be really important to have here is maybe the fact that the opposite sides would be congruent. So think about what parts here would be congruent. So AB here would have to be congruent to the first two letters there, CD. Let's mark that in the picture. So AB, CD. That's perfect, 'cause that's a pair of opposite sides. And then if we look AD, so A and D would match C and B here. So A and D should match C and B just based on the order. So AD, CB, awesome. And that is corresponding parts of congruent triangles are congruent, right? That gives us right there opposite sides of the parallelogram. So think about what we said. If we could show that you have two pairs of opposite sides congruent, that's enough to prove that it's a parallelogram. You can write out the word parallelogram, or you can draw like a little parallelogram and put a P in there for parallelogram. That's fine. And then our conclusion is that A, B, C, D is a parallelogram because we got two pairs of opposite sides congruent. Done. 3-step proof. Easy. All right. For 1B, we want to see, can we do that same proof but a different way? So it does say, as an example, like SSS, SAS, that's not really applicable here because we're not proving congruent triangles, but it's still the idea of what's a different way. So we already showed two pairs of opposite sides congruent. If we start with that exact same given, so triangle ABD congruent to triangle CDB, because it's given, what else could we come up with here? I actually want to save this one for a little recap in class to talk about like what would be a different way we could do it. If you think you can do it, go for it. I'm not going to stop you because then I'll call on you in class and we can chat about it. Otherwise, let's move on to page 36 and talk about the next proof. So for number 2 here, it says we've got angle ABD, so ABD, cool, is congruent to angle CDB. And then angle A is going to be congruent to angle C. So sometimes it helps to just kind of see what's going on here. We're trying to prove it's a parallelogram. So our goal might really be, could we get congruent triangles? And then we could take it from there. Because we already just did that proof. If we can get the triangles congruent, we know how to finish that out. All right. So I'm going to start by listing those givens that I already marked in the picture. So angle ABD congruent to angle CDB, and then angle A congruent to angle C because it's given. Thank you so much. All right. Think about this as a congruent triangle proof. They just handed us a pair of angles right here and a second pair of angles right there. Awesome. So if we have those angles, think about what else would you need to get the triangles congruent? Hopefully, when you think back to that first sheet, we said we could still use things like vertical angles and we could still use reflexive property. So the fact that these two triangles share that middle side, let's take advantage. So we can say that BD is congruent to BD by the reflexive property. That would give us a pair of sides, and then that's enough to get us congruent triangles. So we can say triangle ABD would be congruent to triangle CDB. So I'm just using the order that the letters appeared in up in the angles. And then my reasoning. All right, well, still want to remember what we did back in our triangles unit. I have Post-its sitting nearby, so I'm going to cover it up. If I focus on just one triangle, here's two angles, and it's not the side connecting between them. So it's not ASA. That means I have angle, angle, side here. So AAS would be my reasoning. All right. As soon as I have the triangles congruent, then you can kind of choose from here, how do we want to do this? All right. To show something different, you could absolutely come back to that first proof and just say, okay, I'm going to use CPCTC, get the opposite sides congruent, and then bam, two pairs of opposite sides congruent gives me a parallelogram. That would be perfectly fine. Other options that we could use here, we could use the fact that we have these angles to get the lines parallel, and then CPCTC to get them congruent. So there's a ton of ways to do this. There's no one right way. If you're like, I want to go the easiest way every time, Perfectly fine with that. So to me, the easiest way, just as an FYI, would always be to use the two pairs of opposite sides congruent. All right. So in that case, I can say AB is congruent to CD, and I could say AD is congruent to BC because of corresponding parts of congruent triangles are congruent. And then step 5 would be to go right to saying that ABCD is a parallelogram. And that would be because of two pairs of opposite sides congruent means this thing has to be a parallelogram. So we got these congruent, we got those congruent, that'll do it. I'm only not switching gears because we'll go back and do number 3 together. All right, we're going to skip, that's 1B together. We're going to skip number 3. So again, mark that one as a little recap. We'll do that in class. Let's finish up with proof number 4, because 4 is a little bit of a challenge. It's a great proof, so it's worth looking at together. All right, here, take a look at what you're being handed before we just hop on in. You're being told that A, B, C, and D, F are straight lines. So it's just clarifying that those are nice straight line segments. So when you do a proof and they just give you like those random little pieces, just add it in the first given. You don't have to do anything with it. All right. Let's see. We're told that A, C, F, D. So this big quadrilateral is a parallelogram. Cool. And then we're also given BC is congruent to DE. If you want to throw it in there now, go for it. So BC is congruent to DE. All of that is given. All right, let's look at where we're working towards. So we want to work towards being able to say that A, B, F, E is a parallelogram. That's our goal. All right, so we know that the big quadrilateral is a parallelogram. We want to prove that this little guy inside is also a parallelogram. All right, so as we work our way through this one, there's so many things that we could take advantage of. But think about what all the parallelogram properties have. So the fact that this big figure is a parallelogram is going to mean that those opposite sides are parallel. That could definitely be useful. It means opposite sides are congruent. And maybe we can use these and do a little subtraction to get our way back over here. I'm thinking that sounds like a good plan. So let's use the fact that we know that these sides are parallel, and let's start there. So we can say that A, BC is parallel to DEF, if you will, there, because parallelogram tells me that opposite sides are parallel. I like that. All right, well, we're at it. We can say that ABC, or just feel free to call it AC, that's fine, is congruent to DEF there. And that's because a parallelogram gives us opposite sides congruent. All right. What I'm thinking is we can take the fact that this big segment and this big segment are congruent, use these little segments, and we could do some subtraction to get back to AB and FE here. So let's give it a try. If we do that, all right, this is the longer segment. We're going to subtract from it the shorter segment. So I'm going to take ABC and subtract BC from it. And then that should be congruent to if I take DEF and subtract DE from it. All right, let's rename it. So underneath, this leaves me with AB. This leaves me with EF. And all of that is the subtraction postulate. All right. If you didn't catch it already, we are actually almost done with this proof, because there's one way to prove parallelogram that is a little bit unusual, and it's that case number 4 back on page 34 here. If I can show that one pair of opposite sides are parallel and congruent, that'll do it. We've actually done that right here. Since AB and EF are part of those sides, we got the parallel right there. we just showed that they are congruent right here. So we can actually go right to step 5 and say that A, B, F, E is, you guys can hear Teddy, a parallelogram. He's excited about this. He's like, you did it, yay. And that is because one pair of opposite sides are parallel and congruent. That's going to give me a parallelogram. Awesome. All right. And keep in mind, there's so many ways we could have done this. We could have proved those little triangles on the edges congruent and then gotten sides like AE and BF congruent. So lots and lots of ways to do it. So in case you're like, that is not what I was thinking, that's all right. We will go over those two that we marked for recap in class. Go answer the post video question now. Thanks.